20 says to prove that root 3 is irrational. We approach this in a similar sort of way to proving that root 2 is irrational, and we assume that root 3 is rational. Therefore, it can be written as a fraction. P and Q are integers. We want the fraction its lowest term, so we assume that P and Q have no common factors. And then we square both sides. So 3 is equal to P squared over Q squared. So P squared is equal to 3Q squared. Now, if P squared is equal to 3Q squared, then P squared must be equal to 3 multiplied by, my Q squared must have a factor of 3 in it. So my Q squared is going to be made up of 3 times something. Don't know what the something is, but 3 times something. Therefore, when I square root both sides, I've got 2 3's here. One goes into one P and one goes into the other P. Therefore, P must be a factor of 3. And if P is a factor of 3, then I can write P as something like 3m. So if P is equal to 3m, then I've now got 3m all squared is equal to 3q squared. So this is going to give me 3 lots of 3m squared is equal to 3q squared. Again, the 3's will cancel. So 3m squared, whoops, missed the m out, 3m squared is equal to q squared. And now I've got the same sort of situation as I had above. So now I can say, therefore, Q must be a factor of 3. And I've now got P as a factor of 3 and Q as a factor of 3 when I said they had no common factors. Therefore, I have a contradiction. So root 3 must be irrational.